BBC Two with lockdown learning and Wednesday well-being. Symbols and formulas for you on Bitesize Daily.
I've been thinking, wouldn't it be great if there was a brilliant show that helps everyone stay on top of their studies, that was on, like, daily, Hang on, what? There is one? What, is this show? And I'm the presenter of it. That's a great idea, isn't it? It's Bitesize Daily. School's off, but learning's not. Hello, I'm Katie Thistleton, and welcome to the show that helps you supercharge your brain. Here's a quick warm-up for you. Over the next hour, we're splitting the show into 3 sections. So how long is each section? Yeah, you got it, 20-minute chunks. There's a little bit of maths to start the day. We're starting with the 11 and 12-year-olds, then it's time for the 12 and 13-year-olds, and finally, it's all about the 13 and 14-year-olds. Here's a little taste of what's to come. As it's Wellbeing Wednesday, we've got some great advice lined up to keep your mental health, well, healthy. Then it's all about chemistry, maths and French with our super cool, amazing experts. And to top things off, there's another cracking instalment of The Big Read. Let's get going. Wednesdays here are all about your well-being. So today we've lined up some great advice from BBC Own It about what you can do if you're feeling a bit down in the dumps. Take a look at this.
Step 1. Head to the calmer side of the internet. Sometimes we need to take a deep breath and relax.
You can find relaxing sounds like the waves of the ocean or the rainforest, or even 5 minutes mindfulness exercises.
I've managed to find my calmer side of the internet, relaxing giant turtles. I love it. It really does calm me down.
Express yourself.
You might not always want to share how you're feeling with others, but it is really important to find a way to express your emotions.
This could be as small as scribbling angrily onto a piece of paper.
Or typing a note on your phone to describe how you're feeling.
Whatever it is, the most important thing is getting those feelings out of your head and into the real world.
Time for some science, and today it's the chemistry classic, the periodic table. And here to explain the H to the C's to the N's and the O's, it's our super scientist extraordinaire, Dr. Tim Gregory.
Hello, Katie.
Hello, Dr. Tim. Now, we've got part of the periodic table here. I'm seeing lots of letters. It's a little bit like a giant game of Scrabble. But what do they all mean, and what is the table actually used for?
So this is the periodic table, and each letter on it represents a different element. We call these letters symbols. And an element is a pure substance made from only one type of atom. And there are quite a lot of elements. There are something like 100, and each has a unique symbol made up of a letter and sometimes 2 letters. The table is used to arrange the elements, and we put chemically similar elements together in groups.
Amazing. Thank you very much, Dr. Tim. Well, before we move on, here's some more information to help us understand the basics of chemical symbols and formulae.
Chemical symbols and formulas. Every element in the periodic table is represented by a unique chemical symbol, like O for oxygen or Mg for magnesium. Chemical formulas represent compounds or elements where more than one atom are bonded together. They often, but not always, have little numbers called subscripts that show how many atoms of each element are present in one molecule of a compound. The chemical formula for magnesium oxide, MgO, tells us that there is 1 atom of magnesium for every 1 atom of oxygen. Butane, which has the chemical formula C4H10, has 4 carbon atoms and 10 hydrogen atoms. And the formula of sulfuric acid is H2SO4. And this tells us that 1 molecule of sulfuric acid contains 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms.
OK, Dr. Tim, what's next then?
All right, take a look at the periodic table there. Are there any symbols that you recognise, any elements that you might know?
How about O for oxygen?
Yeah, perfect. How about any others?
I recognise Fe, but if it's got 2 letters like that, does that mean that it's 2 elements combined?
Not quite. Now remember, on the periodic table, we only put elements, not compounds. Fe is actually iron, and you can tell this is an element because it's got an uppercase F followed by a lowercase e. Some elements have 2 letters in their symbol because there are more than 100 elements, but there are only 26 letters in the alphabet, so we have to double some of them up.
Oh, OK, so why is it Fe and not IR, like a shortened version of iron? That'd be much easier to remember, wouldn't it?
It would be easier, but, you know, the history of who discovered these elements and when and where is really long and complicated and interesting. And the symbols for some of the elements are left over from their old names. For example, the symbol for iron, Fe, comes from the Latin name for iron, ferrum.
Oh, wow, I'm learning lots here, sir. How about W? Is that one water?
Not quite. W is actually the element tungsten, and the W symbol comes from the mineral in which tungsten is found, called wolframite. And tungsten is actually what the filament of some light bulbs is made from, the little spiral filament that lights up when you switch it on.
Oh, this is all great for my next online group quiz. Thank you very much, sir. If water's symbol isn't W, then what is the symbol for water?
So water isn't an element, it's a compound. And remember, we only show pure elements on the periodic table.
So what's a compound, then?
A compound is a pure substance which is made from more than one element. And atoms, they chemically bond together in a fixed ratio to make a compound. And this means we can describe these compounds with a chemical formula. So since water is a compound, it means its chemical formula is made up from elements that we can pick from the periodic table.
So which chemicals is water made up of?
So it's made of two elements, oxygen, which you've already found, and hydrogen.
OK, let me find hydrogen. OK, there it is. So H is H2O. Water's H2O, of course it is. What's the number 2 all about, though?
So let me write it down to explain. So we've got water with the chemical formula H2O, just like that. Now, we always put these numbers down at the bottom when we're writing chemical formula. And this number, it shows how many of each type of atom we have in the compound. And the 2 is because for every 1 oxygen atom, there are 2 hydrogen atoms in water. And if we were to draw the molecule, it would look a little bit like this. So we've got our oxygen atom, and then we've got our 2 hydrogen atoms, H2O, water. And when a compound forms, there isn't always an equal number of elements. For example, water, there are 2 hydrogens and just 1 oxygen. And we use the numbers to show how many of each atom there are in a compound. Now, another one you'll have heard of is carbon dioxide.
Yeah, so that's carbon and dioxide. So is oxide oxygen?
Yes, perfect.
And di means 2, so dioxide means 2 oxygens.
Absolutely spot on, exactly right.
So carbon dioxide means a carbon plus 2 oxygens, so that's CO2.
Excellent. So if we write this down, we've got CO2, we've got 1 carbon atom and 2 oxygen atoms. And if we draw it, it will look a little bit like this. So we've got our 1 carbon atom, we've got 1 oxygen there, and another oxygen there, CO2, carbon dioxide.
Lovely drawings. Thank you very much, Dr. Tim. Well, there you go. If we have sparked your interest in chemical formulae, then check out tons more about elements and compounds on the Bitesize website. Now, Dr. Tim, you're staying with us for our next section, The Big Read, because I know you love a good book. In this week's Big Read, we've been reading The Diamond of Drury Lane by Julia Golding. This book has whisked us back to the 1790s and an area of London called Covent Garden. It follows Cat Royal, an orphan who lives at the back of the theatre on Drury Lane. Yesterday, Cat overheard a conversation while hiding. Mr. Sheridan was speaking to another man, asking if he has the diamond. I'm so excited to find out what happens next. And to tell us more is a superstar actress and legend, Joanna Lumley, OBE.
The diamond will be with you later tonight. We can slip our jewel across town without anyone noticing. So Mr. Sheridan had not been as deficient in taste as I thought. The choice of play was deliberate, I noted. Good, good, said Mr. Sheridan, relaxing a little. Would you like to come in for something to take off the chill? I have a few bottles stashed away in my room. Of course you do, Marchmont said, with a knowing leer at one of England's most celebrated drinkers. I dare say I could force down a drop of something. The river was damn cold tonight. The 2 men stepped back into the theatre. I kept very still, hardly daring to breathe. I would have got away with it, too, if the fastening of the man's cloak had not snagged on the curtain. He turned to tug it free and caught sight of a pair of white stockinged legs peeping out. "What's this?" Marchmont barked. I felt my arm seized in a fierce grip as I was wrenched into the open. 2 fingers pinched my ear, dragging me upwards, so I had to stand on tiptoes or part company with my earlobe. I squealed with the pain and tried to push him off. "A spy? What have you heard, girl?"
Oh, it sounds like things are going to kick right off, doesn't it, Dr. Tim?
It really does. You know, this book is so great, but I do hope that Kat is going to be OK.
Yeah, it sounds like this diamond is really valuable. It even seems as though Mr. Sheridan has put on this play just to get the jewel across town.
Yeah, the narrator says the choice of play was deliberate. It's not cheap to put on a play, so he must think he's going to make a lot of money off it. It does seem like these two might have been scheming for a while, though. I think that they know each other fairly well.
Yeah, Mr. Sheridan invites in Marchmont for a drink and he says yes, so they must be fairly good friends. What do you think will happen to Kat next? I mean, the men were quite aggressive towards her. It mentions a fierce grip and a squeal of pain, 2 fingers pinching her ear, wrenching her up.
Yeah, those bits really got me worrying about Kat. I hope that they won't hurt her anymore.
Yeah, well, we'll have to find out tomorrow, won't we? Thanks a lot, Dr. Tim. If you're enjoying the book too and you want to read it in full, check out your local library to see if you can read it online. And don't forget, if you're interested in any other books we've read over the past few weeks, just search Daily Lessons on the BBC Bitesize website. OK, time for our second subject of the day. OK, so I'm primed and ready for all things maths. And to help, it's maths magician, Mr. Gibson. Hello, sir.
Hello, nice to be here.
So pleased that you're here with us today. We're looking at prime numbers, so can you remind us what a prime number is?
Yeah, of course. A prime number is a number that only has 2 factors, itself and 1. So, for example, 11. It can only be made by multiplying 11 by 1.
OK, so what are prime numbers used for?
Well, in cryptography, for example, which is the study of secret codes, that relies heavily on prime numbers. This is because factorising very large numbers is hard and it can take computers quite a long time, especially if that number is prime. So they can help with computer programming, online shopping, banking, basically keeping all of our information encrypted.
So prime numbers are basically keeping my carrots and milk safe in my online shop.
I mean, I guess you could say that. Now, what I'm going to show you today is how you can use prime numbers and find them using the sieve of Eratosthenes.
Wow, that is a mouthful.
OK, the sieve of Eratosthenes basically helps us identify the first prime numbers up to 100. It was created by Eratosthenes, which was a famous Greek mathematician just like Pythagoras, and we're going to look at how we can find the first prime numbers.
OK, great. So prime numbers can only be divided by themselves and 1, and prime numbers only have 2 factors. So that must mean that the first prime number is 1.
Do you know, a lot of people think that, but actually 1 is not a prime number because it can only be divided by itself, which means it only has 1 factor.
Ah, OK, so number 1 is not a prime number. OK, so that must mean that the first prime number is 2 because 2 can only be divided by itself and 1.
Exactly, so 2 is our first prime number, which means I can circle it here. Now, 2 is the only even prime number, which means we can cross off all of our multiples of 2, as they're not going to be prime numbers because they'll always have 2 as a factor.
Oh, good point. So you can get rid of 4, 6, 8, 10, 12 and keep going like that. That's amazing.
Now, I'm not going to keep going here, but what we can do is look at our next prime number. What we would do is we would lose half of those numbers. So next would be 3.
Yeah, OK, so 3 can only be divided by 1 and itself can't be divided by anything else. So, yeah, 3 is our next prime number.
Exactly. Now, if 3 is a prime number, that would mean...
That means all the multiples of 3 can't be prime because they have 3 as a factor, so you can get rid of 6, 9, 12, 15, 18...
Exactly, and we could keep doing all of this on our 1 to 100 board and find all the prime numbers below 100.
Well, that's my evening sorted. That sounds like a party, doesn't it, sir?
Exactly.
Thank you very much, Mr. Gibson. If you want to put your knowledge to the test on any of today's maths, then head over to the Bitesize website. Or if you want to brush up on more maths topics, check out Teacher Talks online. Just search BBC Bitesize Teacher Talks. But before we move on, here's a quick recap of what a prime number is.
A prime number is a special number that can only be divided by 1 and itself. It makes them a pain for this fella who likes to divide things into neat, equal piles. Let's dig further. Take the number 3. 3 is a prime number. Its only factors are 3 and 1. So it can only be divided into one group of 3 or 3 groups of 1. There's no other combination. Now, 4 is not a prime number. As well as groups of 4 and 1, we can also divide 4 into 2 groups of 2. Oh, here we go again. This isn't going to end well. 5 is a prime again. It only has 2 factors, 1 and 5. You can keep going higher and higher, finding bigger and bigger prime numbers, like 7, 11, 13, and even 997. But don't forget, number 1 doesn't count because it only has one factor. Sorry.
Bonjour, comment ça va? Yeah, you've guessed it, our pick of the day is all about the fabulous language, French. And to help us out today, Monsieur Alan is here to teach us all about sports. Vive le sport!
Bonjour, Katie. Yes, we're going to be talking about the sports that we do or don't do. Je joue au foot, mais je ne joue pas au tennis. So I play football, but I don't play tennis.
Oh, this should be loads of fun. I play lots of different sports, so this will be good. Now, to start us off, here's something to get us thinking about the things we like to do.
Regardez attentivement.
What he said.
Talking about what you like to do in French. Moi, j'aime le sport. J'aime le foot. I like football. Elle aime le cyclisme. She likes cycling. And if you don't like something, you sandwich the verb between ne and pas. Je n'aime pas la natation. I don't like swimming. And if you're talking about something you do in your spare time, jouer, to play, is really useful. Je joue au basket. I play basketball. Elle joue de la guitare. She plays guitar. Then there's faire, to do. Je fais de la gymnastique. I do gymnastics. Il y a beaucoup de choses à jouer et à faire. There are lots of things to play and to do.
Hopefully that got you thinking about the activities you do and what you enjoy. Let's get started, shall we?
So, Katie, I have a question for you. Est-ce que tu fais du sport? Do you do sport? To say that you play a ball sport, use jouer à, to play. So you would say, je joue au, and then the name of the ball sport.
OK, so if I wanted to say that I play football, that would be je joue au foot.
Très bien, Katie. And if you want to say I do a sport, you say je fais du or de la, and the name of the sport. That's I do. For example, je fais du vélo.
I ride a bike.
Bien. Now, if you want to say that you don't play a ball sport, you need to say je ne joue pas au or à la, and the name of the sport. That means I don't play. For example, je ne joue pas au golf.
I don't play golf.
And if you don't do a sport, you say it like je ne fais pas de, and the name of the sport.
OK, so je ne fais pas de ski et je ne fais pas de gymnastique. I don't ski and I don't do gymnastics.
Très bien. You did very well to use de for both le ski and la gymnastique, as you need to say je ne fais pas de for both masculine and feminine words.
I see, I'm pretty proud of myself. So how do you actually know when to use jouer au or à la and faire du or de la?
You use au and du for a masculine sport and à la and de la for a feminine sport.
OK, but how do you actually know if a word, for instance, the name of a sport, is masculine or feminine?
It's a good question. It's not always obvious, so it's best if, when you learn a new word, you also learn whether it's masculine and used with le or un, or feminine and used with la and une. Here's a tip, though, for remembering the names of sports. They're almost all masculine, except that the sports that end in an E, like la pétanque, bowls, la gymnastique, gymnastics, or la boxe, boxing.
Merci, Monsieur Alan. Thank you very much. And if you want more of this, I know I do, check out the Bitesize website for tons more French top tips. Well, 11s and 12s, that's our time together done. Thanks for joining us. But remember, the brain cell boosting opportunities don't end here. For more on what we've covered today, head to the BBC Bitesize website where you'll find brilliant bite-sized gems. Before we move on to the 12 to 13-year-olds, here are some final words of wisdom from our resident in-house health guru.
Just a little reminder from me, Dr. Ryder, that exercise is a super useful thing and it can help you establish a routine right now. So whether or not it's a jump around in the morning before you start your work, a lunchtime break, or even something after you finish your studies in the evening, just a big stress buster to shake off the whole day, then do it. It will really, really help you.
Right, 12 and 13-year-olds across the UK, are you ready? These next 20 minutes are all about you. Coming up, we've got some fabulous content and some fabulous names ready to supercharge your brain cells and send your learning into overdrive. Here's what's on today's show. It's Wellbeing Wednesday, so to kick us off, we've got some great advice for, yep, you guessed it, your well-being. Then we're getting scientific with chemistry and the pH scale. Next, my fave, it's the big read and A Wrinkle in Time. Love that title. Then it's time to delve into maths with some fascinating factors. And we're wrapping it all up in French. Magnifique. Wednesdays here on Bitesize Daily are all about your well-being and looking after your mental health, which is so important in lockdown. So today's top advice is from Josh Fletcher, who's got some great tips to help you if you're feeling a little bit or a lot anxious.
Try not to get so absorbed in the worries, and because it is temporary, but because your world has been made smaller, try and make sure that that world is full of things that are nurturing for you. Look after yourself in terms of your hygiene. If you are feeling a bit trapped, I think you're all right. If you've got a garden, go chill out there. Also be mindful of the fact that if you're in a smaller space, you might have more triggers there, whether it's triggers for anxiety or triggers for annoyance or anger. For me, I work a lot with anxiety, so I would look at maybe if you're someone who likes your own space, then get people to respect that space and take yourself away. If you're someone who gets triggered by the news, turn the news off. You know, the news is often filled with things that aren't happy and they're very, very worrying. It's okay to have some time away from that.
OK, time to get scientific because it's chemistry time. And to help us decipher the world of chemistry, it's our very own scientist, Dr. Tim Gregory.
Hello, Kate.
So nice to have you here, Dr. Tim. But can I ask why you brought half the contents of your kitchen cupboards with you today?
Yes, all of these items are to help us to understand acids, alkalis, and the pH scale, which is what we're going to be looking at today.
OK, brilliant. Well, I know what acids are. They're nasty chemicals which can burn your skin and make it all blistery, aren't they?
Acids can be like that, yes, but not all acids are that dangerous. We eat food which is acidic, for example, lemon juice that you might have on your pancakes. So what we're talking about today is the pH scale, which is a scale of acidity that runs from acids at one end all the way up to alkalis at the other.
OK, so acids are on a scale and they're not all going to burn your skin off. Does that mean that an alkali is at the opposite end of the scale and is really safe?
Alkalis are at the opposite end to acid, yes. But alkalis, just like acids, they can be dangerous. Bleach, for example, that we've got here today, this can be really bad for you if you get it on your skin. We all know to be very careful with bleach in the household.
I'm so careful with my bleach in the household that I just leave my boyfriend to do all the cleaning. Thank you very much, Dr. Tim. Before we delve even further into this, here are some more amazing facts about the pH scale.
The pH scale. The pH scale measures how strongly acidic or alkaline a solution is, using a set of values from pH 0 to pH 14. When pure water is dropped into a solution of universal indicator, the indicator stays green. This indicates a pH value of 7 and tells us that water is neither alkaline nor acid, but neutral. Acidic solutions have pH values less than 7. Stomach acid turns universal indicator paper a strong red colour. This indicates a pH value of 0, the strongest value of acid. Alkaline solutions have pH values more than 7. Toothpaste will turn universal indicator paper blue, indicating a pH value of 9, which is a weak alkali.
OK, so we've talked about acids and alkalis, and we just heard that there's neutral on the scale too. It's got a number, 7.
Yes, that's exactly right. Slap bang in the middle of acid and alkali is neutral, which means it's neither acidic or alkaline. A neutral solution has a pH of exactly 7.
What do you mean by solution, though, Dr. Tim?
A solution is a mixture of two different substances, where one of those substances is a liquid, usually water, and all of the bottles in front of you today contain solutions of one type or another.
Oh, OK, got it. So an acidic solution has a pH of 0 and alkalis have a pH of 14.
Almost, but don't forget all of the other pH numbers too. Acidic solutions have a pH value less than 7, and they get increasingly acidic towards 0. Alkaline solutions, on the other hand, they have a pH value of more than 7, and so they get increasingly alkaline upwards towards 14.
OK, let's bring this back to reality, shall we? You've got all this stuff here that you've brought with you. So are these acids or are they alkalis?
Tell you what, Katie, let's have a game of acidic, alkaline, or neutral.
Wow, Dr. Tim, you didn't just bring the contents of your kitchen cupboard, you also brought that jacket. Look at that!
Beautiful, isn't it?
Yes, very shiny, that lovely sequin.
Thank you.
What's this game then?
All right, it's nice and simple. All you have to do is tell me which of these solutions are acidic, alkaline, or neutral by moving them to the correct side of the table. Now, 2 of them we've already talked about. We've talked about lemon juice and bleach.
Yeah, so I was quite surprised to learn that bleach is alkaline and lemon juice is acidic, so we've got those on the correct sides.
Yeah, absolutely. Now, what about vinegar? Let's start with that.
I love vinegar, but it does have a really sort of sharp taste. I think it's quite tangy. I think it's an acid.
Absolutely. Vinegar is an acid. It's also great on your chip butties.
Oh, it's lovely.
Now, what about orange juice?
Orange juice, again, I feel like that is quite acidic and it's like lemon juice, isn't it? Surely orange juice and lemon juice are surely similar.
Perfect. You've got them all right so far. That orange juice has got that sort of citrusy, tangy, sharp taste to it that's acidic. Now, what about toothpaste? What if I told you that toothpaste has got a pH of 9? Where would that go?
So if it's got a pH of 9, does that mean it is a little bit alkaline?
Absolutely, yeah. Remember, neutral is pH 7, and going upwards you get more alkaline. So a pH of 9 is an alkaline, albeit a weak one. Now, milk, on the other hand, what if I told you that that's got a pH of slightly less than 7? Where do we think that might go?
Oh, so it's kind of sort of neutral, but a little bit towards acidic.
Perfect. It's almost 7, but not quite. It's just on the acidic side of neutral, just below 7.
I'm surprised by that.
And finally, last but not least, water.
Oh, water. Is water really alkaline?
Not quite. Water has actually got a pH of 7.
Oh, it's neutral, of course. That makes perfect sense.
Well done. Top marks there. Perfect.
Oh, that was fun, wasn't it? Well, we got through this, but is there a proper scientific way to test a solution to see what its pH is?
Yes, there's a proper scientific way to test this. Doesn't require a jacket like this. All you need is an indicator. An indicator is a substance that changes colour depending on if it's added to an acid or an alkaline.
And what colour does it turn?
On the pH scale colour chart, we can see this. With a neutral solution, the indicator will turn green. If you add an indicator to an acidic solution, it will turn progressively more yellow and then red as you go down the scale to more acidity. Whereas with an alkaline solution, it will turn progressively more bluey and purpley as you go up the scale towards higher alkalinities.
So if it's really acidic, it'll look just like your jacket then,
Exactly.
so,
pH 0.
Thank you very much, Dr. Tim. Well, I think we need to see an indicator at work. And as always, for more information on the pH scale and to put your knowledge to the test, just head to the Bitesize website.
We can use a universal indicator to work out the pH levels of different solutions. If the solution goes green, then it's neutral. If the solution goes red, then it's very acidic. And if the solution goes purple, then it's very alkaline. In fact, if you go through the pH scale, you can get all of the colours of the rainbow.
This week's big read, A Wrinkle in Time by Madeleine L'Engle, has been enthralling. It tells the most extraordinary adventure story of Meg, her brother Charles Wallace, and their friend Calvin O'Keefe, which begins on a wild night when a strange visitor comes to Meg's house. Yesterday we heard how Meg defended her little brother by tackling some boys. We also learned that Meg refers to herself as a delinquent and that her father is away. I cannot wait to find out what happens next. And here to tell us more, it's only Manchester United superstar Jessie Lingard.
The window rattled madly in the wind, and she pulled the quilt close to her. Curled upon one of her pillows, a grey fluff of kitten yawned, showing its pink tongue, tucked its head under again, and went back to sleep. Everybody was asleep, everybody except Meg. Even Charles Wallace, the dumb baby brother, who had an uncanny way of knowing when she was awake and unhappy, and who would come so many nights tiptoeing up to the attic stairs to her. Even Charles Wallace was asleep. How could they sleep? All day on the radio there had been hurricane warnings. How could they leave her up in the attic in the rickety brass bed, knowing that the roof might be blown right off the house? And she tossed into the wild night sky to land. Who knows there? Her shivering grew uncontrollably. You asked to have the attic bedroom, she told herself savagely. Mother, let you have it because you're the oldest. It's a privilege, not a punishment. Not during a hurricane, it isn't a privilege, she said aloud. She tossed the quilt down on the foot of her bed and stood up. The kitten stretched luxuriously and looked up to her with huge, innocent eyes.
Right, well, I know you love a good book, Dr. Tim, so what did you think of that? Pretty atmospheric, right?
It was fantastic. You know, the way those windows rattled madly in the wind and that rickety brass bed, all of that language really brought it to life for me.
Yeah, I loved the line tossed out into the wild night sky. It makes the storm seem intimidating, but also quite romantic, like the wildness of the night.
Yeah, I know what you mean. I'm not sure how scary the storm really was, though. Do you think Megan could be slightly exaggerating, perhaps?
Maybe. I mean, it would have to be a pretty massive storm to pull the roof off a house. She is shivering uncontrollably, but maybe she just got herself a bit worked up.
Yeah, I noticed that the cat doesn't seem bothered. I thought that were quite funny, yawning at the start and stretching at the end.
Yeah, and they say animals can sense danger, so maybe the cat knows more than Meg. I thought it was interesting that she's been listening all day to the radio.
Yeah, do you think that it might mean that this book is set in the past, maybe?
Maybe, or maybe she's just a really big fan of my show on BBC Radio 1. Not that I do the weather, I don't get involved with
There hasn't been a mention of a mobile phone yet, so maybe it is in the past. I find it all very intriguing so far.
Well, hopefully we'll find out very soon. They say patience is a virtue, but if you can't wait, why not visit your local library online to get the audio or ebook? And if you're interested in any other books that we've read over the past few weeks in the Big Read, check out Daily Lessons on the BBC Bitesize website. Right, time for our second subject of the day. We've got to get primed, be ready to factor a lot in and deal with multiple things. That's right, it's maths, of course. And to help us today is our very own mathematical maestro, Mr. Gibson. Hello, sir. What have you got for us today?
OK, so today we're going to be looking at factors and multiples of numbers.
Oh, that's exciting. Let's get started then. First, what are factors?
OK, so factors of numbers are whole numbers which divide into the number fully. That means they don't leave a remainder.
OK, so let me just pick a number at random. Let's say 48. So the factors of it would be all the whole numbers that divide into 48. So that's 1, 2, 3, 4, 6, 8, 12, 16, 24, 48.
Yeah, every number there is going to be a factor of 48. So divide by 2, you get 24. Divide by 12, you get 4.
OK, so we've got factors sorted, but what are they actually used for?
Well, factors are great for simplifying fractions. So let's say we had 2 sixths and we also had 6 twelfths. And we want to decide which fraction was bigger. We can use factors to work that out. Now, when we're simplifying them, we need to divide by a common factor of both of them. Now, that's a number that can divide into the top, the numerator, and the bottom number, the denominator. So, looking at 2 sixths, well, the top and bottom both divide by 2, which means that this can be simplified to 1/3. Now, if we look at 6 twelfths, the top and bottom both divide by 6, which means that this can be simplified to 1/2. Now, we all know that 1/2 is bigger than 1/3, which means that 6 twelfths must be bigger than 2 sixths. You always want to simplify your fractions whenever you're working with them.
Yeah, definitely. Fractions are really hard, and that made it so much easier. How about multiples, then?
OK, so multiples of numbers are all the numbers that it will divide into. So, Katie, what are the first 7 multiples of 7?
Oh, so it would be 7, 14, 21, 28, 35, 42, 49, which is basically the 7 times table.
Exactly. Now, there is a really easy way of remembering the difference between factors and multiples. Because if you just think then, you said times tables. Now, another way of calling them are our multiplication tables, because we can see the word multiple. Some people like to remember about factors being in a factory, putting things together to make a bigger number. How I like to remember them is generally that factors are smaller than the number and multiples are generally larger.
Thank you very much, Mr. Gibson. Very helpful. If you want to put your maths knowledge to the test, then check out the Bitesize website for loads more fun-packed quizzes. Or take a look at Teacher Talks online. Before we move on, I'll leave you with a quick look at how factors and multiples are used in the real world. Check this out.
For restaurant The Bar, all our napkins comes in pack of 100. Here I've got 6 packs, which is 600. It's easier to use in multiples because I know the restaurant uses 3 packs a day, which is easier for us instead of counting 300 napkins a day.
So £5, please.
£5?
Yes, please.
Cheers, darling.
These glasses comes in a pack of 4. So if I need 40 glasses, that means I need to order 10 packs. Multiple packs make it much easier to reorder the stock.
Today we are making the pavlova. We are going to do 40 pavlovas on each tray. So we are doing 5 rows of 8.
Bonjour, comment ça va?
Oh, I know what that means, sir. Hello, how are you?
Moi, ça va très bien.
Oh, French, our final subject today. Monsieur Alan's here to help us with our pronunciation. So what are we going to be learning about today, sir?
Well, we're going to be talking about ce que j'aime faire, what I like doing. J'aime regarder la télé. I like watching TV. Or perhaps what you dislike doing. Je déteste ranger ma chambre. I hate tidying up my bedroom.
Oh, I do hate tidying up my bedroom, but I tell you what, being able to say that in French is amazing. It sounds much better, doesn't it? Before we get into that, let's find out what my French friends Amélie and Michelle like doing.
Voici ton café.
Merci. Ce week-end, c'est mon anniversaire et je vais le fêter avec mes copains Valérie et Georges. Et toi, si tu veux?
Oui, bien sûr. Alors, qu'est-ce que tu veux faire?
Je ne peux pas décider.
Qu'est-ce que tu aimes faire pendant ton temps libre?
J'aime aller au cinéma et j'aime écouter de la musique.
Et le sport? Quel est ton sport préféré?
J'aime aller au bowling avec mes copains. Et toi? Quel est ton sport préféré?
J'aime faire du cyclisme et jouer au basket. Mais mon frère préfère rester à la maison et jouer aux jeux vidéo. C'est nul.
Le week-end dernier, j'ai fait de la natation avec ma sœur. Et après, nous sommes allés faire les magasins. Qu'est-ce que tu as fait?
Le week-end dernier, j'ai joué au badminton avec mon père. Mais ton anniversaire, comment tu vas le fêter?
Je sais que Georges aime faire du parcours.
Mais c'est trop dangereux.
Valérie préfère jouer aux jeux vidéo.
Mais c'est trop ennuyeux.
D'accord. Nous allons aller au bowling et après, nous allons manger une pizza en ville.
Bon choix.
So, Katie, if you're asked, qu'est-ce que tu aimes faire? What do you like doing? You can say, j'aime assez, I quite like, or j'aime bien, I really like, or perhaps j'adore, and then name the activity.
So if I wanted to say I love listening to music, that would be...
J'adore écouter de la musique. If you want to say that you don't like something, je n'aime pas beaucoup, I don't like something very much. Je n'aime pas du tout, I don't like something at all. Or je déteste, I hate, and then name your activity.
So if I hate playing video games, what would I say?
Je déteste jouer aux jeux vidéo. Now, if you want to build on that sentence and explain why you like something, you use parce que c'est, because it's, or parce que je trouve ça, because I find that, and use adjectives to give a positive opinion.
OK, so how would I say I love listening to music because it's relaxing?
J'adore écouter de la musique parce que c'est relaxant.
How about I hate playing video games because I find that boring?
Je déteste jouer aux jeux vidéo parce que je trouve ça ennuyeux.
Merci, Monsieur Alan. That was ace. To practice your French and many other languages for that matter, head over to the BBC Bitesize website where you'll find tons of great content. C'est très bien. Well, 12 and 13s, that's it for today. We've taken you through a world of science, maths, and we've had a trip to France. I'm exhausted. But if you're still hungry for more, then log on to the Bitesize website. And to watch this or any of our Bitesize daily shows again, just search Bitesize on BBC iPlayer. Now, before we move on to the 13 and 14-year-olds, it's over to our resident in-house doctor with some nice advice on how to keep your body active as well as your brain.
Hiya, Dr. Rada with just a quick reminder for you. It's super important to keep on top of your studies and your schoolwork right now, but it's just as important to get active, move your body to feel better. We know that a healthy body equals a healthy mind. Our mind and body are not separate from each other. So whatever you fancy doing, if it's in your garden, your kitchen, your living room, get up, get moving, get active, get your heart rate going, and I promise you, you'll feel better and you won't regret it.
Attention 13 and 14-year-olds across the UK, are you ready? This small but perfectly formed chunk of Bitesize Daily is all about you. Get ready for brilliant experts, top teachers and famous faces galore. Hold on to your sofas. Here's what's coming up. It's Wellbeing Wednesday, and today we're all about looking after your mental health when it comes to social media. Then it's time to get scientific with chemistry, discovering the reactivity of metals. Next up, it's our big read and another instalment of A Good Girl's Guide to Murder by Holly Jackson. Maths comes after that when we focus on multiples. And wrapping things up, we're looking forward to having a perfect weekend in French. Let's crack on with the show. Here at Bitesize Daily, every Wednesday is all about well-being and keeping our mental health healthy. So today we've got some great tips and advice from psychologist Honey Lancaster-James about why taking a break from social media can really help our well-being.
Sometimes the world around us can actually affect our mental health as well. If you find yourself going on social media and then feeling worse about yourself or feeling low in mood, then you might need to put in place some limits on how much time you're spending online.
I tend to have a social media detox. So when I feel that everything's getting a bit too much for me and I'm feeling a bit insecure about myself, I just take some time away from my phone and focus on myself and not what everyone else is doing.
Right, time to get stuck into science with one of my favourite subjects. It's chemistry. And here with some great reactions, it's Science Man of Steel, Dr. Tim Gregory.
Hello, Katie.
Hello, Dr. Tim. What have you got for us today?
All right, so today we're going to be looking at metals and how reactive they are. Different metals have different reactivities, which means they react at different rates. Some metals are very unreactive, and this means that they don't easily take part in chemical reactions. They'll quite happily sit there not doing much.
Oh, do you have an example of that?
Well, is that an engagement ring that I see there, Katie?
It is indeed. It's nice, isn't it?
Very, very nice. And do you know why we make rings out of metals like platinum and gold?
Is it because they're rarer, so they're more expensive, and that makes them more special? Oh, and I've noticed that cheaper rings, they might not be platinum or gold, and they leave like a green mark on your finger.
Yeah, exactly. And what do you think that green mark might be?
I suppose it's a chemical reaction. So does that mean that gold and platinum must be really unreactive?
That's exactly right. They're not completely unreactive, but gold and platinum are a lot less reactive than most other metals, so they won't react when you've got them on your finger.
So what happens to a reactive metal then?
Well, some metals corrode, like iron, for example. Iron rusts when it reacts with the air, and that's because it's quite a reactive metal. That's why it's important to use the correct metal for the right task, or you might end up with a rusty engagement ring.
Oh, I wouldn't be happy with that. Here are some more fascinating facts about the reactivity of metals.
The reactivity of metals. The reactivity series lists some of the most common metals, from the most reactive to least reactive. Some metals are very unreactive. This means they do not easily take part in chemical reactions. For example, platinum does not react with oxygen in the air, even if it is heated in a Bunsen burner flame. Some metals are moderately reactive, so they interact with other chemicals slowly, like iron oxidizing to form iron oxide, known as rust. And some metals are very reactive. Reactive metals easily take part in chemical reactions. Magnesium ignites when heated and burns quickly and brightly with a brilliant white flame.
OK, so some metals are more reactive than others. Is there a list of all of them from the most reactive to the least by any chance?
Yes, there is a list, but there are about 90 metals on the periodic table, so we don't tend to list all of them. There are some common ones, though, which are really useful to know, like these.
OK, I think I've heard of pretty much all of these. So out of all of these, potassium is the most reactive and platinum is the least reactive.
That's exactly right, and we call this list the reactivity series. And a nice way to remember it is by thinking of a mnemonic. That's a sentence where the first letter from every word in the list is the same as the first letter in the words of the sentence. This is one for the reactivity of metals, for example. Pond slime can make a zoo interesting. The long, crinkly sort goes purple.
I love it.
So can you remember which words goes next to each?
OK, I'm going to have a go, and I'm going to start right down here at the least reactive. So this one is platinum, I remember.
Perfect.
Then we've got gold.
Yep, great for jewellery.
Silver.
Another one that's great for jewellery.
Copper.
Yep, copper's next.
Lead.
Lead, perfect.
Tin.
Yep, tin.
Iron.
Perfect.
Zinc.
Zinc.
Aluminium.
Perfect, that's what cans are made out of.
Oh, it's a spelling test now. Magnesium.
Yep, magnesium.
Oh, I'm stuck with these last few.
So the last three, they're the most reactive on the reactivity series. And going upwards, we've got calcium, sodium, and potassium.
Oh, wow, I didn't even realise they were metals.
Yeah, it's interesting. A lot of these elements you don't think of as metals, and that's because we usually find them as compounds. We never really experience them in their pure forms. For example, sodium, we mostly come across it in table salt, which is sodium chloride. Or in the case of calcium, we come across that as limescale in a kettle, which is calcium carbonate.
Wow, that makes sense. Amazing. What could people do at home to help them get to grips with this?
So when I memorised the reactivity series, I came up with my own mnemonic to help remember them.
Oh, OK. Get thinking of your own mnemonic then. It's really fun to come up with those. And we'd love to hear how you get on. And remember, for more information on the reactivity of metals, head to the Bitesize website. But before we leave it there, take a look at how metals react when heated. Hang on, I'm going to come up with one now. People say carrots make a zingy, interesting, tasty, layered cake. Silly ginger pineapple.
Perfect.
Well, the thrilling big read this week has been A Good Girl's Guide to Murder by Holly Jackson. 5 years ago, schoolgirl Angie Bell was murdered. Everyone thinks Sal Singh killed her, but Pip isn't so sure. She chose the case as the topic for a final project and started to uncover secrets. Could the real killer still be out there? Yesterday, Pip knocked on the door of the house of the Singh family. When the door was opened, Pip asked, "I was wondering if I could borrow a jiffy of your time." To tell us what happens next is our superstar celeb. Take it away.
Oh, God. This is what happened when she was nervous or backed into a corner. She started spewing useless facts, dressed up as bad jokes. And the other thing, nervous Pip turned 4 strokes more posh, abandoning middle class to grapple for a poor imitation of upper. When had she ever said jiffy before? What? Ravi asked, looking confused. Sorry, never mind, Pip said, recovering. So I'm doing my EPQ at school, and what's EPQ? Extended Project Qualification. It's a project you work on independently alongside A-levels, and you can pick any topic you want. Oh, I never got that far in school, he said. Left as soon as I could. Well, I was wondering if you'd be willing to be interviewed for my project. What's it about? His dark eyebrows hugged closer to his eyes. It's about what happened 5 years ago. Ravi exhaled loudly, his lip curling up in what looked like pre-sprung anger. Why? He said. Because I don't think your brother did it, and I'm going to try to prove it.
Well, to discuss all that in more detail, Dr. Tim is still with us, and I know you love a good read, so what did you think of that? There was a lot of dialogue there, wasn't there?
It's just fantastic. And yeah, the dialogue can really show a character's personality, can't it? You know, Pip is kicking herself for saying jiffy. It's really interesting how she started speaking in an upper-class manner.
I know. I mean, I've definitely done that before when you're, like, nervous and you're speaking to somebody important. You feel like you have to put on a voice and speak a certain way. I think it makes her seem much more relatable that she did that.
Yeah, absolutely relatable. And Ravi's language makes him sound a bit confused by the whole thing, I think. You know, he kept saying, what?
Yeah, I mean, this girl's just turned up at his door out of the blue, and then she asks him about what happened 5 years ago. His reaction to being asked is expressed really interestingly in the description, I think, his lip curling up. It gives you a really visual idea of how he's feeling.
Yeah, absolutely. And you also get a really clear idea in this piece that the two characters are very different people. Pip is working on a school project and really going overboard by the sounds of it, whereas Ravi, on the other hand, mentions that he left school as soon as he could.
Yeah, it seems the author could be setting up the characters for a little bit of a clash of personalities, doesn't it? Oh, I cannot wait to find out what happens in the next extract tomorrow. If you want to read the book at home, then try your local library's website. You might be able to read it online there. And if you're interested in any other books we've had in the Big Read, just check out Daily Lessons on the BBC Bitesize website. Right, time for our second subject of the day, and to help us, we've got our magnificent mathematician, Mr. Gibson, on hand.
Hi.
So what mathematical delights have you got lined up for us today, sir?
Hi, well, today we're going to be teaching you about HCF and LCM, but also the difference between the two.
OK, who is HC what and LC who?
OK, so HCF stands for the highest common factor. To find the highest common factor, obviously, we first need to look at common factors. So what are the common factors of 8 and 12?
OK, so that's the numbers that divide equally into 8 and 12. So factors of 8, we've got 1, 2, 4 and 8. And factors of 12, we've got 1, 2, 3, 4, 6 and 12. So the common factors are 1, 2 and 4.
Fantastic. So what would the highest common factor be?
That would be number 4.
Superb. OK, so now let's have a look at LCM. Now, LCM stands for the lowest common multiple. To find lowest common multiples, again, we need to look at multiples. So let's have a look at the same numbers, 8 and 12.
OK, so if I wanted to find the lowest common multiple of 8 and 12, I need to first do the multiples of 8 and the 12 times tables too. So we've got 8, 16, 24, 32, 40, 48, those are the multiples of 8.
Fantastic.
And multiples of 12, we've got 12, 24, 36, 48 and 60. So 24 and 48 are the first few common multiples.
24 and 48 are common multiples, so that would mean that the lowest common multiple is going to be 24.
Amazing. So how do we use HCF and LCM in the real world?
Well, I've got an example for us. Let's say I was having a barbecue in my garden and I wanted to have some burgers. Now, my bread rolls come in packs of 6 and my burgers come in packs of 8.
Oh, how annoying.
Now, I want to make sure that I have a burger for every roll without any wastage. What we're going to have a look at is the LCM, the lowest common multiple, to work that out.
OK, so we need to look at the 6 times tables. So we've got them there. We've got 6, 12, 18, 24, 30 and 36. And the 8 times tables, we've got them there too. So we've got 8, 16, 24, 32, 40 and 48. So the lowest common multiple here is 24. So that means you would need to make 24 burgers to get the right amount.
Now, that's a lot of burgers, but if we have a look, I've got 1, 2, 3, 4 packs of rolls, and I've got 1, 2, 3 packs of burgers.
Oh, that's amazing. Thank you so much, Mr. Gibson. That was ace. If you're looking for something else to do other than eating burgers, then head on over to the Bitesize website or check out Teacher Talks for even more brilliant tips on all things maths. Bonjour, comment ça va? That's right, it's time for French, and here to help us out is Monsieur Alan. So what have you got in store for us today?
Bonjour, Katie. I'm going to show you how to answer the question, tu as passé un bon week-end? Did you have a good weekend? And, qu'est-ce que tu as fait? What did you do?
Oh, well, I had a lovely weekend. Can't wait to tell you all about it, sir. But first, let's see what Natu has got up to as she stays at home all week to try and forget about her now ex-boyfriend. Wonder what happened there, then.
Mais il y a un problème. Rester à la maison, c'est ennuyeux. Alors voici ma solution. J'ai préparé un emploi du temps pour toute la semaine. Lundi, j'ai fait du dessin. Mardi, j'ai fait de la photographie. Mercredi, j'ai joué au volley. Je préfère le beach volley, mais comme j'avais un peu froid, j'ai gardé mes vêtements. C'était ennuyeux. Je l'aimais toujours, mais je n'aimais pas les disputes. Non, c'est fini. Je ne m'ennuie pas. Jeudi, j'ai fait de la natation dans ma piscine privée. L'exercice, c'est bon pour le moral. Vendredi, j'ai fait les activités du cirque. Samedi, je fais un peu de randonnée. J'aime ça. Et dimanche, j'ai joué aux échecs.
Okay, are we ready to speak French?
When you want to say what your weekend was like and answer the questions, tu as passé un bon weekend? Did you have a good weekend? And qu'est-ce que tu as fait? What did you do? Remember that as you're speaking about the past, you need to use the verbs in the perfect tense, or passé composé in French, which is made of two bits. J'ai, from avoir, to have, or je suis, from être, to be, and a special form of the verb called a past participle.
So how do I know if I need to use j'ai or je suis?
Well, you use j'ai with most verbs. So you can say, I watched TV and I did some drawing. J'ai regardé la télé et j'ai fait du dessin. Only a small number of verbs need je suis. They're verbs like aller, to go, or rester, to stay. Remember to make the past participle agree like an adjective when you're writing.
Like, je suis allé au parc. I went to the park.
Oui, exactement. If I said, it would be je suis allé au parc. If I said I stayed at home, it would be je suis resté à la maison.
Merci, Monsieur Alan. J'adore le français. And if you want to check out more, then go to the BBC Bitesize website, where there's tons of brilliant content and quizzes to put your knowledge to the test. Well, to all you 13 and 14-year-olds out there, that's it. That's all we've got time for today. But if we've sparked your interest in any of the topics covered, then don't forget to check out the Bitesize website, where there are loads more activities, games and quizzes to put your knowledge to the test. And if you want to let us know how you're getting on, just use the hashtag BBC Bitesize Daily. Before you go, here's one of our in-house doctors with some top advice about the importance of exercise. I'm off for a jog. See ya. Bye.
Dr. Rada, brain teaser here. So what does exercise and laughter have in common? Well, they both release endorphins, which are those chemicals in our body that make us feel happy. So not only will getting active help your physical health, it'll also make you feel happy too. So don't forget to get up and do some exercise.
Catch all your favourite CBBC shows every weekday on CBBC.
What are you doing?
Join in the fun at 5 o'clock, when you can catch up with your favourite faces every weekday.
And more!
That's all of your faves, and always at 5 o'clock.
Time the lab is scarier, scarier, and more dangerous than ever before.
So switch on the fun with your faves at 5, weekdays on CBBC.